Artificial Intelligence by Melissa Mitchell. Over the months that follow, I'd started paying attention to this discussion surrounding these questions. I started to notice the slew of articles, blog posts, and entire books by prominent people suddenly telling us we should start worrying right now about the perils of superhuman AI. In 2014, the physicist Stephen Hawking proclaimed the development of full artificial intelligence could spell the end of the human race. In the same year, the entrepreneur Elon Musk, founder of the Tesla and SpaceX companies, said that artificial intelligence is probably our biggest existential threat, and that with artificial intelligence, we are summoning the demon. Microsoft's co-founder Bill Gates concurred. I agree with Elon Musk and some others on this and don't understand why some people are not concerned. The philosopher Nick Bostrom's book, Superintelligence, on the potential dangers of machines becoming smarter than humans, became a surprise bestseller despite its dry and ponderous style. Other prominent thinkers were pushing back. Yes, they said we should make sure that AI programs are safe and don't risk harming humans, but any reports of near-term superhuman AI are greatly exaggerated. The entrepreneur and activist Mitchell Kapoor advised, human intelligence is a marvelous, subtle, and poorly understood phenomenon. There is no danger of duplicating it anytime soon. The roboticist and former director of MIT's AI lab, Rodney Brooks, agreed, stating that we grossly overestimate the capabilities of machines, those of today and those of the next few decades. The psychologist and AI researcher Gary Marcus went so far as to assert that in the quest to create strong AI, that is general human-level AI, there has been almost no progress. I could go on and on with dueling quotations. In short, what I found is that the field of AI is in turmoil. Either we are within spitting distance of true AI, or it is centuries away. AI will solve all of our problems, put us all out of a job, destroy the human race, or cheapen our humanity. It's either a noble quest or summoning the demon. Since the 2010s, our family of AI methods, collectively called deep learning or deep neural networks, has risen above the anarchy to become the dominant AI paradigm. In fact, in much of the popular media, the term artificial intelligence itself has come to mean deep learning. This is an unfortunate inaccuracy, and I need to clarify the distinction. AI is a field that includes a broad set of approaches with the goal of creating machines with intelligence. Deep learning is only one such method. Deep learning is itself one method among many in the field of machine learning, a subfield of AI in which machines learn from data or from their own experiences. To better understand these various distinctions, it's important to understand a philosophical split that occurred early in the AI research community, the split between the symbolic and the sub-symbolic AI. Spoiler alert, multi-layer neural networks, the extension of perceptrons that was dismissed by Minsky and Papert as likely to be sterile, have turned out to form the foundation of much of modern artificial intelligence because they are the basis of several of the methods I'll describe in later chapters. I'll take some time here to describe how these networks work. Multi-layer neural networks. A network is simply a set of elements that are connected to one another in various ways. We're all familiar with social networks in which the elements are people, and computer networks in which the elements are machines. Inspired by statistics and probability theory, AI researchers developed numerous algorithms that enable computers to learn from data, and the field of machine learning became its own independent subdiscipline of AI, intentionally separate from symbolic AI. Machine learning researchers disparagingly referred to symbolic AI methods as good old-fashioned AI, or GOFAI, GOFAI, and roundly rejected them. By the 2020s, molecular assembly will provide tools to effectively combat poverty, clean up our environment, overcome disease, and extend human longevity. These are some of Kurzweil's predictions. By the end of the 2030s, brain implants based on massively distributed intelligence nanobytes will greatly expand our memories and otherwise vastly improve our sensory, pattern recognition, and cognitive abilities. Uploading a human brain means scanning all of its salient details and thus reinstating those details into a suitably powerful computational substrate. The end of the 2020s is a conservative projection for successful brain uploading. A computer will pass the Turing test by 2029. As we get to the 2030s, artificial consciousness will be very realistic. That's what it means to pass the Turing test. I set the date for the singularity at 2045. The non-biological intelligence created in that year will be 1 billion times more powerful than all human intelligence today. The writer Adrian Gray rightly referred to Kurzweil's singularity prediction as nothing more than the belief in a technological rapture. Kurzweil's bases all of his predictions on the idea of exponential progress in many areas of science and technology, especially computers. To unpack this idea, we can consider exponential growth.